Hello everyone, in this video we're going to walk you through the code and functionality of our Smart Safe project built using an ESP32. This smart system uses several components, an ultrasonic sensor to detect objects approaching, a 4x4 keypad for password input, an LCD display for user feedback, a servo motor to lock and unlock the safe, and Blink, which is a platform that connects the project to your phone to send alerts and display data in real time. Now, going through the code, first we have the libraries we need. These handle Wi-Fi and Blink communication, the keypad input, the servo control, and LCD display. Then we define the pins used for the ultrasonic sensor, which are the first two, and the servo motor, which is the last one. Now, these are the credentials needed to connect to the Blink app and your Wi-Fi network. This here is the authentication code for the Blink app, and this SSID is our network name and the network password. In this section, we have the LCD and keypad setup. The LCD is initialized with its I2C address, and we define a 4x4 keypad matrix. We also configure which pins on the ESP32 are connected to the rows and columns of the keypad, which columns are G32, 33, 25, and 26, while rows are 27, 14, 12, and 13. Okay, so now we have the password logic variables. It's this part in here. These variables handle the logic of password input. So this password stores what the user types, and correct password is the pin that will unlock the safe. Here we have 1, 2, 3, 4, just like a basic pin. And then safe open keeps track of whether the safe is currently open or closed. That's why it's a bool variable. Here it's false. Now with the setup function, that is this part, we first start serial communications and initialize the LCD and print the welcome message. After, we attach the servo and set it up to 30 degrees, which means that it is locked. And finally, connect to Wi-Fi and the Blink app using the credentials we said earlier. So this next function we have is for measuring distance. It's get average distance function. This function triggers the ultrasonic sensor 3 times and then calculates the average of the valid distance readings that we have. It's this calculus here. This formula, duration times 0.034 divided by 2, converts time to distance in centimeters. Then we go through the main loop. Okay. In the main loop, we first get the distance from the ultrasonic sensor. If it's valid, we print it in the serial monitor for debugging. Then we send the distance value to virtual pin V0 and a binary alert 1 or 0 to V1 depending on whether the distance is below or there's hole, which is 10 centimeters. If someone is too close to the safe and no alert has been sent yet, we trigger a Blink notifications to the user's phone. At the same time, the LCD displays a warning if someone is near the safe. Okay, the next function we have is the keypad logic, which is for handling the keypad input. First, we have this condition that says that if the key of this symbol is pressed, the code will check if the password that the user entered is the correct password. If it's correct and the safe is closed, the servo rotates to 0 degrees to unlock it. And if the safe is already open, then pressing this key again closes it by rotating it back to 30 degrees. And also, when we press this key, and we're entering a pin to the safe lock, it's gonna delete the last character that the user entered. So if the user makes a mistake, they can delete it by pressing this key.
Before we continue watching the rest of the code, let's take a look about how the hardware was incorporated in the box in general.
Okay, so this is all of the electronics part of our project. In the middle we have a breadboard, and here we've connected our ESP32 board, and to all of these pins here we've connected the 4x4 keypad. These are pins GPIO, I believe 32 to 13. We've mentioned it before in the video. We've also connected the echo and trigger pins for the ultrasonic sensor, as well as ground and 5-volt supply. Same with the servo, the out pin and the ground and 5-volt pins. And finally, we have our LCD display with the I2C module for easier connection. And we've connected the ground, the VCC, and the SDA and SEL to the corresponding pins of our ESP32. Also, these lines here is in which we send the data to the Blink app, to our virtual variables. When the safe is unlocked, we send open to our virtual variable 2 to our data stream, and also a 1 to our virtual variable 3, which is the one that controls the remote switch on and off of our servo. And we do the same thing when the safe is closed, except we send closed and 0.
Now we're gonna show how it works physically and how the notification is sent to the phone.
And here first we created a template for our smart safe. And in this template, then we went to the data streams and we created 4 virtual variables for each of the variables that we were managing. We set the configurations for each one of them, and for all of them we set a range. Distance goes from 0 to 400 centimeters, for example, and this is our dashboard. Based on the data stream, we create some widgets that display the data that we are receiving with the sensors. So in the app, we can see how the distance varies when I move objects near or far the sensor. We can see the message being displayed on the LCD2 and the alert LED being activated, as well as a notification being sent to my phone when an object is nearby. So we've set these notifications to only send once every 5 minutes, so the user's phone doesn't get loaded with notifications. And we can also remotely open and close the safe box by controlling the servo, as we are seeing right now, with the switch that we've added to the interface in the app. So now that we've explained how the Blink app connection works, this is a section of our code. As we can see here, we have a condition. If the remote state is equal to 1 and the safe is open, which is basically the same thing, then we set the servo at 0 degrees to indicate that this box is open. The condition is also set to true, and we show this message in our LCD, but most importantly, we set the Blink variable 2 to 1, and the same happens, but with the closing logic, if we want to lock the safe. What we do here is we write these variables in Blink so that we can open and close the safe, but remotely. Okay, so now we're gonna see how the safe works, now that it's all mounted on the wooden box. First, we're going to introduce our pin manually. So if we get near the safe, we can see the alert for an object. It goes away after a few seconds, but now we're gonna introduce our pin by pressing the keypad. As we can see, all of the numbers pressed are displayed as asterisks, so the pin isn't revealed. And we're gonna verify if the pin is correct. If we introduce the correct pin, the safe is unlocked, and now we can access whatever is inside. So if we want to close the door again, we just hold it and introduce our pin again. And we're gonna verify the pin. And now we can see the safe is closed and we cannot open it anymore. Now we're gonna see how the remote control works. Here we have our blink app, and this switch is the remote control for the servos. So we're gonna activate it, and as you can see, the safe opens on its own remotely. If I want to close the safe again, I just hold the door and close it. So that's how our safe works.